Okay, good morning. Okay, good morning. Thank you all for being here this morning. Thank you to those joining us online for the CRIN Project Cafe. I forgot my, there we go. This will work. I promise. Nothing? Okay. I will get us started just until we can move on. CRIN is a network of networks, as many of you know. We bring together individuals, organizations, and any networks that exist that are working with us on our mission to accelerate the development, commercialization, and adoption of clean tech. We work across 7 themes and across 5 sectors. We are an inclusive network that is free to join. And if you have not yet joined, you should join. Joining the network gives you access to, I'll just advance, here we go, gives you access to a lot of the resources that we develop to help our innovators to address the challenges of industry and integrate all of the support services that help us out. As we get going, acknowledgement of the land is an important step towards reconciliation. Today, we're gathering from across Canada. Please take a moment to recognize the land where you reside and work. This event is being hosted from Calgary, where we acknowledge and pay tribute to the traditional and unceded territories of the peoples of Treaty 7, which include the Blackfoot Confederacy, comprised of the Siksika, the Piikani, and the Kainai First Nations, the Tsuut'ina First Nation, and the Stoney Nakoda. The city of Calgary is also home to the Métis Nation of Alberta, Districts 5 and 6. We have a full program today with 5 different exciting projects that we want to hear from. So I will not be spending a lot of time up here. I would like to invite our first speaker, Dr. Yao, who is joining us from the University of Regina to tell us about integrated mobile system for methane utilization and produced water treatment. Dr. Yao has a strong background in environmental engineering. He's currently research administrator at the Institute of Energy, Environment and Sustainable Communities at the University of Regina. Dr. Yao has demonstrated expertise in environmental research, particularly in wastewater treatment, pollutant removal, and the functional materials for environmental applications, and has published a number of high-impact journal articles.
Thank you, Sally and Lindy, for this event. Let me share my screen now. Okay, good morning. My name is Yao. I'm a research administrator at the University of Regina. It's my pleasure here to give you a quick update on this project. The project title is the development of an integrated mobile system for methane utilization and produced water treatment. So it's well known that Canada is very active in oil and natural gas production, especially in Alberta and Saskatchewan. And many oil wells also produce natural gas along with the crude oil and produce water. So this gas is a major greenhouse gases emission source. And methane accounts for about 16% of global greenhouse gases emissions, and this number is 14% for Canada. And within that 14%, oil and gas activities accounts for 68% of Canada's total methane emissions. That's why Canada plans to reduce domestic methane emissions by more than 35% by 2030. So to tackle the methane and produce water simultaneously, the aim of this project is to collect and utilize the methane as a power source for produced water treatment. The objectives include the development of on-site methane gas collection and power generation system, the development of mobile platform for power supply and produced water treatment, development of smart operation and management system, and finally the design and utilization of the integrated mobile system with optimized performance. So we're currently at the halfway of the entire project. The first milestone we reached is that the methane gas collection and power generation module has been successfully developed and tested under various gas emission conditions. The system is comprised of a scrubber, a compressor storage tank, and portable generator. Second milestone is that the produced water treatment module has been developed utilizing electrocoagulation and ceramic ultrafiltration technologies. The test runs has demonstrated effective oil and contaminant removal rate, reducing the need for chemical additives and lowering the energy consumption compared to the conventional technologies. These two tables shows the performance of the produced water treatment system. And the entire produced water treatment module is designed to be integrated into and mounted onto a trailer, which can be easily deployed by a pickup truck. This mobile system can then roaming among multiple sites for produced water treatment. Here are some lessons and challenges we faced so far. So first one is the gas composition. The composition of the collected natural gas can vary significantly between sites, so it will influence the power generation efficiency. Therefore, adjustments to the gas collection system may be required to optimize the power generation. And the second one is the volumes of both methane and wastewater fluctuates depending on the well, the season, and the production rates. For example, one well with very high produced water discharge does not necessarily have high methane emission and vice versa. So despite our data collection efforts, we find there is still a lack of data of the dynamics and relationships between these two key numbers. This leads to the challenge in identifying suitable system capacities for the methane collection and produced water treatment modules. We have made a lot of efforts to improve the energy efficiency of the treatment system so that less energy is required for treating produced water. But we may also considering adding additional power source for the wells which has high produced water discharge but low methane availability. Another challenge we face is regulatory issues. It could be complex navigating environmental and operational regulations in multiple provinces and even across borders. So we will benefit from regulatory support and partnerships with local governments and oil producers. As for the partnerships, this project has been a collaboration between University of Regina, PTRC, and Ground Effect. Both of them have been very helpful and contributed a lot of resources to this project. And in addition, we look forward to work with oil producers for field trials. We also seek data providers regarding detailed methane and produced water emissions for each well, and we also seek regulatory consultants. For the next step is to develop the smart operation and management system. This system is designed to optimize and the operations as scattered oil wells over a larger area. which means the system can cover multiple oil wells in oil field. The system could be capable of determining the desired operation parameters and real-time dynamic routing, and maximizing the overall efficiencies of the methane collection, power generation, and produced water treatment modules. That's all the slides for today. Thank you so much for your attention. Thank you.
Thank you, Dr. Yao. Moving on with our agenda this morning, we have from New Wave Hydrogen, Loie Gunowick. He is Chief Technical Officer and Strategic Advisor for New Wave Hydrogen. He has over 35 years of prior experience as a CEO and director for both large and entrepreneurial companies, including Solex, Sproul, and Hatch. Loie holds degrees in thermal fluids, mechanical engineering, and agriculture, and has guided multiple technologies and companies to commercial success in Canada and internationally. Loie.
Thank you, Sally. Can I use this? Or okay. All right. Thanks everybody for being here today. It's a pleasure to be here. And which button works? There we go. Okay, New Wave Hydrogen, what are we about? We're using a really neat technology called a wave rotor. And what that wave rotor is a rotating bank of shock tubes. And what we're doing is introducing a shock wave inside the wave rotor to create, or really to convert pressure energy into thermal energy. And with that thermal energy, we're driving the methane pyrolysis process. So we really believe that the methane pyrolysis represents a near-term solution to really help those hard to decarbonize industries that can't do without hydrogen. Would also like to point out that the carbon that's produced in the pyrolysis process is also a very important product. There's a lot of need for carbon as we reduce our mining activities, and that needs to be made up over the long term. It's a clean, cost-effective, and scalable technology. Doesn't use water, and we don't produce any CO2 as a result of it. Okay. And I think what's really cool about what New Wave is doing is we're really building off of existing technologies and applying it to a new process, methane pyrolysis. So wave rotors, they've been around for 50 years. They've been installed in commercial applications. There was an automobile that used a wave rotor for a long time. I think you can still find it out there on the market. And we're really putting together the wave rotor with a bunch of other standard components, whether it's a compressor, heat exchanger, cyclone cleaning system, etc. So it's really applying proven process or proven technology to a new process. Using shockwave dynamics, that's nothing new. We've known about shockwaves for a long time. As I said, wave rotors are well known. I should have talked a little bit more about fluidized beds. We're adding a fluidized bed into the circuit potentially, and with a catalyst allows us to drive that pyrolysis reaction at much lower temperatures. Okay, integrated sector benefits for methane pyrolysis. We can use natural gas, clean, green RNG, and it can fit into a lot of different areas. Whether you build it at the edge of the grid, as we like to call it. So, for example, you tap into an existing natural gas pipeline. You don't need to build a lot of new infrastructure. You kit up and you start producing hydrogen, and away you go. So represents a really neat opportunity. We can also take ammonia, if ammonia is being used as a carrier gas for hydrogen, and extract the hydrogen from that. So some of the key accomplishments that New Wave has realized over the last number of years. So we've demonstrated the methane pyrolysis in a shock tube in a laboratory environment. And from that work, we've also developed very complex kinetic models and developed some sensors to actually be able to measure all of that along the way. A lot of work has gone into CFD modeling to help us guide the development of the wave rotor. Everything from very high fidelity 3D models to 1D scoping models, if you will. Of course, we've used the laboratory results to validate the CFD models. We've developed field pilot and commercial designs. There was a first of a kind reactor built here in Canada. So that's kind of neat. Canada hasn't been particularly active in the wave rotor field, but we're now doing it. We've got a research team at BC that have a lot of expertise in wave rotors. And we've also spent quite a bit of time talking to industry. So we have a very good idea where there's an interest in this technology. It could be, for example, in a refinery where they need some additional clean hydrogen. It could be in fertilizer production where you want some cleaner hydrogen. It could also be in a power generation plant. For example, we've talked to some power producers, and if they could get hydrogen, they could easily switch their power turbines to, let's say, a 30-70 blend between natural gas and hydrogen without any trouble, without any changes. They've told us that. And we've also created a lot of IP along the way. As you can see, we've produced 6 new patents, and we've also published quite a few new papers as well. Okay, we're following a pretty structured technology development program. You can see, excuse me, where we are along the way. We've had a great success attracting non-dilutive grant funding to help with our work. And we're moving down the path going forward. A bit slow sometimes, or is that my clicker? You hear my clicker? This is just virtual. Okay, competitive comparisons. Of course, this is always important as you're developing a new technology. Where do you fit? And you can see from a cost and risk point of view, and also with respect to an environmental point of view, we are based on the work that we've done today. We feel we have a very competitive position with our technology. Thank you. There's been a lot of support along the way. Just pulling up the slide here of all the diverse sectors that have contributed to the New Wave journey so far. It's been great to work with a lot of these people. Thank you. And to really just summarize here, we believe we're offering a real opportunity with methane pyrolysis to produce not only clean hydrogen, but also clean carbon. And both of those products we need going forward. So again, it's a novel integration of proven components. We don't use water. Our electricity demand is low because we're really running off of a lot of power or a lot of energy that's already existing in a pipeline. There's no direct CO2. The cost is very reasonable. We don't have to be dependent on build out of infrastructure to be able to implement the technology. It offers a very rapid path to reducing GHG emissions. And as I mentioned, we have broad industry support. Thank you very much.
Thank you, Loie. Our next presentation is from Ling Bai, CEO of VL Energy, a seed stage software as a service company specializing in predictive emissions monitoring systems that optimize energy efficiency and reduce greenhouse gas emissions. Under Ling's leadership, VL Energy secured $1.5 million in funding and achieved key commercial milestones, which I'm hoping we're going to hear about right now.
Thank you, Sally. Get it started. Okay, thank you everyone to join us today. It's right after Thanksgiving. Hope everybody had a really good family time. And yeah, let's go. So VL Energy, I'm founder CEO for VL Energy. We are SaaS company for predictive emissions monitoring system. So it's a complete software-based solution to monitor multi-gas emissions, not only including greenhouse gas, but also other gas streams such as NOx, SOx, H2S, and etc. I guess CRIN, we are part of the community. We used to have an office in the ETC, so Emission Testing Center. We are proud of that. We were here from the grand opening. So grew the team a lot. So we are still in the same building. We are in the West Tower. We are proud of still being part of the community here. So what we did for as CRIN project, we collaborated with Suncor Energy. So we deployed our predictive emissions monitoring system, our Firebag. So Firebag, it was, we picked most challenging co-generation unit to deploy our technology to commercialize this technology. So current situation, this is our technology here. Why do we need to monitor, and previous presentation as well. So why do we need to monitor emissions, right? We want to detect, we want to fix, and we want to monitor, we want to reduce, and we want to achieve the same goal. So I view lots of collaborations from the previous solutions as well. Anyways, as I mentioned, so that's our product. We have a trademark on this name. So it's called ESPAMS, Efficient and Secure Predictive Emissions Monitoring System. It's a regulatory tool actually in Alberta. There's a SAMS codes. That's a regulation that regulates industrial combustion sources that has to be continuously monitored by either a SAMS or a PAMS. SAMS is standing for Continuous Emissions Monitoring System. It's a physical mobile lab on the site. And then our solution is the software solution. It's a full alternative compared to the hardware. So continuously monitor and predict emissions. What is the prediction part? What does that do? So the prediction part is really predicting when the system is going to be down by analyzing the operational data from the existing instrumental sensors reading for combustion sources, such as the cogens, the furnaces, and the boilers. So it's really an AI and machine learning model that is the first and only approved model by the local regulators, that is AER and AEP. So software-based solution, we are looking to help companies to achieve the accurate, feasible monitoring as a regulatory compliance tool from the software. So this is a real dashboard. From our dashboard, we have two options for the dashboard. So the first one is really Power BI. The other one is web-based. So we do auto reporting for the companies as well for different kind of purposes. If it's monthly reporting as a compliance regulatory reporting, we do that. And if it's the data that's needed for ESG reporting and any other types like carbon credits, carbon tax reporting, we do that as well. Different solutions. So current situation, the previous presentations clearly identified how important is the emissions monitoring and the goals that we want to achieve together. So So there's lots of different tools, lots of different technologies, hardware, software, and it's really a collaboration at this current stage. As mentioned to Suncor's Fairbank power plant, this was a really good case, again, sponsored by CRIN. It was such a journey. It's very challenging. We are going to talk about the challenges later, but we are going to talk about what we have achieved. So according to the regulation, the accuracy that's needing to be met is R square of 0.64 according to the local regulation. This regulation is adopted from the US EPA. That is very similar requirement in terms of the accuracy and than the mature testing methodologies. So our model of R square has more than 15% that's exceeding the requirements. So we just want to ensure what we are contributing to our clients is not only meeting, but also exceeding the requirements. That's saving them time, money, collaboration, communications with the third parties. So where are we sitting right now from how do we how did we benefit from this CRIN sponsored project? We have achieved proof of operations, so significant cost reduction, operational efficiency, and also the compliance reliability. In detail here, so because it's a software machine learning based solution, we are achieving approaching 100% of the data availability. That the requirement is really 90%, which is a common challenge for the whole industry right now. So we did publish a white paper with Suncor as a co-author under the Oil and Gas Journal. That's part of the achievement from this project. So lessons learned is us as a startup, you work with a big company and then you collaborate with different departments and different departments, people with different background. How hard is it? How are we speaking the same languages? And when we are talking about instrumental sensors reading, when you're talking to DCS, automation control SCADA system people, it may mean different meaning when compared to when you are talking to environmental regulatory compliance people. So that's a big lessons learned for us as a team, a small team that you deal with different kind of department, different background. Also the adoption resistance. It's been pretty hard in our industry. It's not that we are not open. It's getting much better after the pandemic and all of these years. But how can we do our job, doing our part to promote or not really promote our product, but the resistance? How can we of the adoption? How can we improve as we know our product the best? We know how can they benefit from this product the best. Biggest lessons learned in all of this. So our ask, why we are here, first of all, thank you again for CRIN. It's been a fantastic journey, and we've been working or collaborating with our peers, and also from this ecosystem, we've been, I've been, having the network from the ecosystem that's not only limited to potential customers, our peers, but also investors and all of this. So we are looking for new collaborations, some more pilot projects and commercial contracts. So where we are sitting right now, we have signed up our couple first commercial contracts. So the first one is not SaaS yet, but we are doing this project in the institution on a gas turbine. And then the other project is a 10-year SaaS. So we are deploying on a combined heat and power unit. So we are looking for this kind of collaboration, and whoever is interested, please feel free to contact us. So what's the next? we are expanding the deployment in the new industries, including our energy sector, by expanding to the unregulated market and the regulated market. We have just closed our first round of seed round. It was a pricing round. We are pretty lucky at this timing. So really appreciate that. Again, the ecosystem really works and we are proud of that. So scope, so we are scaling up our technology to some manufacturers and data centers. Is really, we are learning a lot from our potential customers and what's our value proposition, what's our business model, rather than this sector that we've done, right? So that's really good. So benefits, environmental impact, we've talked about preventive maintenance and, the predictions and monitoring, reducing emissions and all of this. Continuous model improvement as the real-time optimization using our tool by the machine learning and AI functionality is what we are looking to improve as a product. So yeah, looking for collaboration, partnerships, and please contact us. That's it. Thank you very much.
Thank you, Ling. Our next speaker is Dr. Haibu Wang. He is the Director of the Energy Services Division of InnoTech and the manager of the AACI Research Program, a large industry and government consortia. He has a PhD in physical chemistry. The areas of his research include in situ, bitumen, heavy oil recovery, process development, and mechanisms in solvent-based EOR processes.
Good morning, everyone, and thank you for your time being here. Okay, this is the project we run. It's different from all the 4 projects updated prior to this. It's an in situ recovery technology. It's a DME assist in situ bitumen recovery process, which is a low GHG technology. And why it's low GHG is in Alberta, we're so familiar with the SAGD, for example. This is the commercially used in situ bitumen recovery, and that use steam. And because it's a high usage of the steam translated into, relatively speaking, pretty high level of GHG formed and water usage. And this particular project is all the same to the SAGD's configuration, just replacing steam by vaporized DME, dimethyl ether, a kind of specialty solvent, and injected into the same reservoir, use the same well configuration, however, at a much, much lower temperature, say below 100 degrees C. And the work we conducted prior to this particular, CRIN project, showing this DME in situ bitumen process can deliver the economic performance almost just the same as the SAGD. However, with 86% of reduction in the GHG emission and almost 80% of less water usage. So those the technology stand before we started this project. And this project is to advance this technology to the TRL 7 by completing the experimental and engineer analysis to further assess the viability of the commercial application and to do a preliminary field test design. In order to support, achieving this objective, this project worked on 6 milestone deliverables. So milestone 1 is the comparative semi-field scale experiment on this DME in situ recovery process and a SAGD process. The physical model used fairly big, 1.5 meters in the length and 80 centimeters tall and 40 centimeters in the depth. it is sand packed with reservoir condition sand to mimic a reservoir condition, and use the asbestos bitumen. And as you can see, the performance from this two experiments showing the oil production behavior basically just right on, one, right on another. So it proved this DME process can compete with SAGD process, oil productivity speaking. And based on this detailed experiment, we were able to look into further. You get the recovery process, and everybody knows the step one is how to get it started. It's called the initialization. Any other way to initialize the communication between the two wells other than just using steam? We know using steam, you can get them communicated. How about a different approach? So through the scanning of the options, and we identified that there is one scheme, which is alternating cyclic injection of the warm DME, same material for this process. And between the two wells, we'll be able to achieve the communication. And then subsequently conducted a physical model experiment. As you can see from the diagram showing there, in a very few cycles, in 1 meter separation, packed with filled sand and bitumen and water, the fluid communication could be established. Based on that one, we build the field scale model where you have to see how long it would take in order to communicate the two wells, which is separated by 5 meters, which can be achieved in 4 months, which is reasonable for a horizontal well-based recovery process. So that was the second milestone. And the third one is, for any recovery process, in order to gain the kind of confidence and help to do the economic assessment and subsequently, the pilot and the commercial scale design, scoping study, field scale simulation is necessary, and the simulation has to be with a certain degree of confidence in it, has to be, adequately reliable, and supported by the physical experiment, which, tested the key process mechanisms. We were able to, build the field scale simulation model, use the generic asbestos geology. So we're able to do the field scale performance prediction. And as you can see, the oil recovery behavior seems to be very reasonable, all in reference to, SAGD. It's like a SAGD-alike process in oil productivity. And so that is only one scenario. In any kind of field application, you have to look a range of the conditions under which the process can be operated. That is the so-called the process optimization. It's our number 4 project milestone. And there are a number of operation parameters being looked into that. And it is found, this process will give increased oil rate when it is operated at somehow increased pressure, which is reasonable because for any solvent-based process, increased pressure means the density of the material in the reservoir is increased. And sure, it impact to the oil is increased. And however, for the solvent-based oil recovery process, how to economically manage the solvent usage is very important. Therefore, recovery of the injected solvent become one of the key elements for this process economic success. And also we found, you run the process at a higher pressure initially and start to, decrease. And at some point, co-inject non-condensable gas all help you maintain reasonable oil production rate and at the same time improve solvent recovery. overall contribute to better economics. Then it's very important to run any field process. You need to know how much cost in terms of when you rig it up, facility cost. We know SAGD will cost this much for service facilities, but for any new processes, what would it be? And based on the result from the project, particularly the field performance prediction using our field simulation model, we were able to generate the production history and produce the fluid characteristics. From there, develop the surface facility for processing the produced fluid. Because you need dry bitumen, and then you have a separate solvent for reuse, and overall, given the earlier stage of the project, this one, we only attempt to do a class 5, which is plus minus, 50 to 100 kind of variation in the cost estimate. We did 2 models. One is the 1,500 barrel per day, which is a pilot scale facility. And also we looked into how about a 40,000 barrels a day. That is a commercial scale operation. And so get some idea. So the processing flow sheet has been developed, and key equipment list has been determined and been sized, and all the streams involved in the processing has been modeled for its required mass balance and energy calculation. So the key part is this: for any solvent related process, the residual solvent in the dry bitumen has to be pretty low, and the solvent recovery has to be significantly high in order to really have a good economics. And for this project, through the work, and we have identified the process initialization scheme as a strong IP potential for the new IP protection. And as well, any process new, the potential impact on the environmental side has to be evaluated to see if there's any requirement in order to really get the idea how to address it for its, field implementation. So in summary, for the 6 milestone deliverables, 2 are completed, 3 are very close to the completion, 1 currently is being worked on. Okay, so that is the current stand of project. Thank you.
Thank you, Haibo. Okay, I will ask our 4 speakers to join us up here on the stage for a bit of a Q&A. And Dr. Yao is still online. Excellent. So Omar, Haibo, Ling, and Loie, please join us. Thank you. So if you have a question in the audience, please put your hand up and we will bring a mic to you so that those online can also hear us. But just to start us off, we've heard a little bit about some of the challenges to commercialization. So I thought I would hear a little bit more from Haibo. If you can tell us a little bit more about what challenges you're anticipating to commercializing this technology.
Thank you, Sally. That is really important. For this new recovery technologies, the next step, which is so important, the systematic field pilot, because commercialization, you cannot really jump to there without really piloting it. And the pilot demonstrated its implementability and performance and economics, because the real economics really, you can do it after you have done a pilot. So right now, this project, intended to advance, and we believe it will meet this goal to get it to the 7.7. That is the knocking the door for the piloting. So, and Omar, you come from one of the big oil companies, and so each gate connected to the different stages, and you would agree. So that is really one critical step you cannot really skip. And so this project actually has 3 major oil companies as a partner: Imperial Oils, Sinol, and Suncor. And also the CMG, who is a specialized reservoir simulator developer, and also contribute a lot. And so we are actively, interacting with the oil sand companies to see their earlier stage of interesting in, taking the ball and for the next yard.
Ling, I'm going to ask you the same question. You talked about adoption resistance. From a SaaS perspective, are you finding that there are challenges to adoption that include, for example, the sharing of data or outcomes from other clients, or are they very different?
They're very different. So from different stages as well. So 2 years ago, when we are trying to drive the adoption, the challenges were really, what is PAMS? What is machine learning? What is AI? What is all of this? And after 2 years of the effort, right now is, what's your differentiator? And how are you comparing to this company? But that company is not the same thing. There is still some piece of education, but it's the market as well. I think it's the knowledge sharing. It's the big part right now is the communication. Because when something is new, kind of new in the market, it's really nothing is new. It's just improvement on some angles and innovations. This right. So, combination of communication, knowledge sharing, speaking the same languages, I think is very important. And also from our team as a technical team, we newly developed the business side, but we're not there yet. That's another part from internal.
Right.
Yeah.
Okay, I'm actually going to pick up on that thread in a second, but before we do that, I'm wondering, Dr. Yao, if you have anything to add about challenges to commercialization, particularly from the perspective of, are you actually working with regulators right now? Are you consulting with any regulators?
No, I haven't at this stage right now. Our biggest challenge right now is to find available data. So we ask a lot of collaborators and from our own connections, and because this is a new idea, so many of them don't have a continuous monitoring data for their methane emission from each well. I know Omar has a great device for monitoring the whole entire emission from the entire site, but we need continuously feel well-specific data of the emission. So it's a little bit hard to get it. That leads to the challenges we cannot. We are looking to design a product that can fit as many wells as possible, but with a lack of the data, we'll try to do it from a small scale and maybe expand the design after the smaller pilots.
Great, thank you. I'm going to ask Loie actually to slightly switch directions towards IP development. You talked about 6 patents currently in process. Can you tell us about your IP strategy and what the challenges you've had there?
Well, I think the IP strategy just kind of falls out of the development process. As I mentioned, we're using existing or proven technology on a new process. And so as you push forward trying to make that new process work, you learn a lot of things. And so whether it's things like, new sensors to be able to measure what's happening in a shock tube, or it could be a new configuration of a wave rotor to be able to, let's say, adapt that known technology to let's say, an operating regime in a new envelope. So that I would say is really what's happening at New Wave. It's the typical discovery process as you go forward, and it's like, nobody's ever done this before. We should capture that.
Okay, I'm going to go one last question. I'm just going to jump back to Ling and a comment you made earlier about effectively socializing the technology and making it more, making industry more familiar with the technologies. But also, I'm wondering how you guys seek to differentiate yourselves in the marketplace, given that we have heard a couple of different technologies that are monitoring emissions.
Absolutely. Like I mentioned, Sally, thank you for the question. To us, it's really a collaboration. Every single scenario is a little bit different, and the demand from a customer is very different as well. Like Dr. Yao just mentioned, we need a well-set continuous emissions monitoring. So we are not that, right? So we are continuous emissions monitoring for multi-gas, but based on industrial combustion source. So we are currently linking to Caterpillar. We are going to do a conversation. They are interested of deploying our technology on their engines. So it's another angle of all of this. How do we differentiate? I don't think we have to differentiate. It's really a collaboration in different kinds of scenarios, depending on who is needing what, what kind of timing as well. But if I have to talk about how do we view ourselves to be like leading the industry, or we view is really the capability of being technology of multi-gas and continuous emissions monitoring at a feasible pricing.
Thank you so much, all of you, for our audience here, our audience online, and our amazing speakers. Dr. Yao, thank you so much for joining us today. Omar, Haibu, Ling, and Loie, thank you so much for being here. If you haven't already joined the CRIN network, please go online and join the network. The network is only as strong as the number of members in it and the roles they play, of course. Our next Project Cafe is October 29th. Join us for some further exciting technologies. Thank you.
Thank you, everyone.